In this video we're going to look at the calculation of partial derivatives for multivariable functions. For example, here's question 2 from chapter 6. We've got the function given here, z equals 3x squared plus 4y squared minus 2x squared y, and we want to calculate all the partial derivatives, second order partial derivatives and cross partial derivatives. Well, as you can see, it's easy to calculate the first partial derivatives. We simply set one of the variables as constant and differentiate with respect to the other. That gives us the two values here. dz dx equals 6x minus 4xy, and dz dy equals 8y minus 2x squared. And to calculate the second order partial derivatives, we do the same. So d squared z dx squared equals 6, and d squared z dy squared is equal to 8. Now, when it comes to the cross partial derivatives, we take the first order partial derivatives and differentiate with respect to the other variable. So, for example, in calculating d squared z dx dy, we take the partial derivative with respect to y and differentiate with respect to x, and that gives us minus 4x. And the same again for d squared z dy dx, which again will give us the same answer, minus 4x, and that's a general feature of this type of problem. Next, we take a look at the calculation of the total differential. Now, we're going to take an example again from the questions in the textbook. This is z of x and y equals x log y. Now, the total differential is given by the expression dz equals the partial derivative dz dx multiplied by dx plus the partial derivative dz dy multiplied by dy. So we first calculate the partial derivatives. dz dx equals log y, and dz dy is equal to x over y. And then we simply write down the total differential. dz equals log y dx plus x over y dy, and this will come in useful later on.